equations of the form y equals mx plus b are represented on the plane by lines. Let's see a few examples, such as y equals x. The points on the plane which satisfy this equality make up a line. Let's see some of those points. So for example, 1, 1 is such a point, 2, 2, negative 5, negative 5. Now let's plot some of those points. And we can draw a straight line through those points. This line makes a 45-degree angle with the x-axis. Let's see another example of an equation of this form. Y equals negative x. Again, here's some sample points in the plane that satisfy this equation. So let's say if x equals 1, what should y equal? If x equals 1, then y equals negative 1. If x equals 2, y equals negative 2. If x equals negative 1, y equals 1. So here's 1, negative 1, 2, negative 2, negative 1, 1. And that's this line. In fact, we only need to find 2 points in order to graph a line. So we could have used, for example, these 2 points, or these 2 points, or these 2 points. Now let's look at a slightly more complex linear equation. So let's look at y equals 1/2 x minus 1. So here m, which is the slope, is 1/2, and b is negative 1. Now, as I said before, we only need 2 points that satisfy this equation in order to graph the line. And it turns out that there are 2 points that are quite easy to find for any linear equation. So you can always make x equal to 0, and this is called the y-intercept. And this is because this is where the line intersects the vertical axis. So when x equals 0, on the x-axis you're always here. But on the y-axis, you have to figure out where you are. So if x equals 0, we plug 0 in here to get y equals negative 1. So we know that the y-intercept is negative 1. So here's 1 point, our first point on the line represented by this equation. Now if we set y equal to 0, we get the x-intercept. Because when y equals 0, the point lives on the x-axis. when y, let's see what we get when we set y equal to 0. We have 0 equals 1/2 x minus 1. Now what are we solving for? We're solving for x. So then we bring the 1 over. 1 equals 1/2 x, which means that x equals 2. So when y equals 0, x equals 2. 1, 2. So there you have it. The line that goes through these points is represented by the equation y equals 1/2 x minus 1. So now let's do another example of an equation for a line. This is still the equation of a line, even though it doesn't look like this, because you can just rearrange the terms. So you can rearrange the terms so that y is isolated. Y equals negative x plus 2. So in this case, the slope equals m equals negative 1, and b is actually the y-intercept, because that's when x equals 0, you always get b. So this is the y-intercept equals 2 in this case. So let's graph this. When x equals 0, y equals 2. So x 0, y equals 2. And then when y equals 0, we have 0 equals negative x plus 2, which means that x equals 2. So when y equals 0, x equals 2. And we get this line. So this is the line represented by this equation. Distance between 2 points. So given any 2 points, x1, y1, x2, y2 on the plane, we simply use the Pythagorean theorem to find the distance between those 2 points. So you have the x1, y1, and x2, y2. We want to find this hypotenuse of this triangle. But this distance is simply y1 minus y2, and this distance is simply x1 minus x2. And then so what is the length of the hypotenuse? Is this root of x1 minus x2 squared plus y1 minus y2 squared. So let's look at a concrete example. Let's just say the first point, P1, equals negative 1, 2, and the second point, P2, is 3, negative 1. So then what is the distance between P1 and P2? It is equal to the square root of x1 minus x2, negative 1 minus 3 squared plus 2 minus minus 1 plus 1 squared. So distance equals root 4 squared plus 3 squared, 16 plus 9, 25 equals 5. Point between 2 points. Again, we're going to use P1 and P2. So we're trying to find the coordinates of this point, which is the midpoint between P1 and P2. Notice that the x value for this point is exactly between x1 and x2, and that the y value is exactly between y1 and y2. So you really just have to find the midpoint in both directions. So midpoint is x1 plus x2 divided by 2, and y1 plus y2 divided by 2. Because that's how you would find these coordinates. So let's look at an example. Let's look at P1 equals 2, negative 1, and P2 equals 3, 3. Alright, so first let's draw those points. P1 is 2, negative 1, and P2 is 3, 3. That's this triangle. So how would we compute this midpoint right here? So midpoint is x1 plus x2, 2 plus 3 divided by 2, and then the y value is negative 1 plus 3 divided by 2. That's 5 halves, and 3 minus 1, that's 2 over 2, 1. Okay, that's 2.5 and 1. And let's see if that looks roughly correct. So here's 1 in the y direction, yes, and here's 2, and this looks like it's about a half. So it's good to, when you get your answer, see if it makes sense in terms of what the triangle looks like, and in this case it does. Instead of being given a line, we instead have 2 points, and we need to find the equation of the line. So let's take an example. Let point 1 be 0, 5, point 2 equal negative 1, negative 1. And I'm just making up these points. What is the line that goes through these 2 points? Well, remember that when you have y equals mx plus b, m stands for the slope, which equals rise over run. And what would the rise be in this situation? It would be the difference in y values. So y2 minus y1 over x2 minus x1. What's y2? It's negative 1. And y1 is 5. x2 is -1, and x1 is 0. So we have that the slope equals -6 over -1, which is 6. So now we have our m value. How do we get our b value? Well, we only need to know 1 point on the line in order to get the b value, because we can plug in y and x, and we know m already. So here's the example. We have y equals 6x plus b. Must be satisfied by both points. So for example, taking P1, we have 0 equals x and 5 equals y. So 5, so this is using point 1, equals 6 times 0 plus b, which means that b equals 5. So therefore we have y equals 6x plus 5 is the equation of the line that passes through these 2 points. Now you can check to make sure that these 2 points lie on this line by plugging in the x and y values. So we already used P1 to get the b value. Let's check if P2 lies on this line. That means that we plug in -1 for y equals 6, again, times -1 plus 5. So is that true? In other words, does P2 lie on this line? Let's see. Is -1 equal to -6 plus 5? Yes. So P2 does live on this line, P1 does live on this line, and so this is the equation of the line that passes through P1 and P2.